Hi, everyone. Very good to see you. I've not been in London for a while. I live up in Scotland, so it's great to be in the city again. Yeah, this is me. I'm Phil Leggetter. I work at Hookdeck. Out of interest, you've all heard of Stripe. Who's heard of Hookdeck before? 2, 3 people. That's amazing, because now you all have. So that's fantastic. So we build platforms and tools that empower developers to build interoperable and dependable event-driven systems. That's quite a mouthful. That's why I've read it. One of our products is something called an event gateway. And it sits in between, as you can see in this diagram, between webhook providers and the applications that you're building. As you can see as well, we've processed over 100 billion webhooks and billions each month now for tens of thousands of developers. And we directly experienced the pain of building that infrastructure, but also helped solve problems for developers that use our platform. So this talk covers those lessons learned of building that infrastructure so that you can do it yourselves if you want to. And also the best practices in general around handling webhooks. So when people think of webhooks, they often think an HTTP post request, maybe HMAC, some sort of signature validation, verification. But behind every webhook, there's an event. So data is created, updated, deleted. There's a workflow that's progressed, or there's some sort of state change. And that means you're building an event-driven architecture. So as you can see, at Hookdeck, we say webhooks are the gateway drug to event-driven architectures. So when working with webhooks, all the same kind of EDA, event-driven architecture principles can apply. They're just hidden behind HTTP. Now, who thinks webhooks are hard? Yeah, okay, not many. Who handles 100 billion webhooks every few months? Right, okay. So they're hard at scale, right? So it doesn't have to be that scale. It can, if you do get to a point where you're genuinely ingesting large volumes of webhooks, you will start to see problems. So the problems here are, you've got the same challenges as event-driven architecture. So you've got out-of-order events, you've got duplications, you need to manage retries, you've got to implement queuing systems, dead letter queues, you've got alerting, a whole bunch of stuff around like these asynchronous messaging platforms. You don't control the publisher with webhooks, which is different from when you're building your own EDA and there's a message queue that maybe you can speak to a team and say, hey, stop. Well, normally they're pull mechanisms, right? So you're pulling data from a queue, whereas webhooks are push. So you can't say to Stripe or to Twilio or to Shopify, hey, just stop sending me those webhooks now. They're just going to keep sending them. And not only that, they're going to start retrying them. So these problems compound. The other thing is there's inconsistencies. Now, you're not always working just with Stripe webhooks. Who integrates more than one webhook provider? Nobody. Just Stripe. Who works with webhooks? Why are you here? No, I mean, you're learning about webhooks. Anyway, quite often, if you are working with external platforms and you are consuming webhooks, you will consume webhooks from more than one provider. And as I said, you won't just be working with Stripe, provide great DX. You'll be working with numerous providers who all have different retry mechanisms. They'll have different guarantees, timeouts, different signature schemas. We've implemented about approaching 30 different ways of signing webhooks on our platform. Now, there is standard webhooks, which is a great progression, but it's almost too late. There's too many providers out there already doing webhook signing differently. So this is a big problem. And there's also fragmented developer experience. Again, Stripe offer a good local developer experience, so does Shopify, but numerous platforms don't. And you ultimately need to build that worst common denominator, the common denominator, which is worse from the providers you're working with. So the first challenge is you can't trust the order of webhook delivery, and you will get duplicates certainly at scale. You're working with HTTP, you're going to get duplicate events. So, for instance, you might receive a subscription updated and then a subscription created. And if you just follow that blindly and you get the updated and you try and update around the database that doesn't exist, you're going to have an error. Same with created after the updated. How is that going to work? You're going to have various problems. So you can't process them as you've got to provide validation and some logic in there. you get a duplicate, so invoice paid. That triggers some logic that sends an email and says thanks to the customer, or even processes a payment, tries to charge them twice. Well, obviously not the case with invoice paid, but you get the idea. You can't follow these things blindly. You have to think about your own logic in here. So you need to design defensively. Another example, you get cancelled, maybe a deletion after an updated. Sorry, before an updated. So if you're building event-driven systems, you need to understand idempotency. It's difficult to say, so I'm going to try not to say it too many more times. You can't, when you perform the same, when an attempt is made against your system to execute an operation, the same result must occur if that same operation occurs multiple times. So in event-driven systems, especially with webhooks, everything has to be idempotent. You don't want duplicate inserts, you don't want duplicate emails, duplicate refunds. Those actions have consequences, and you've got to protect against them. There isn't a one-size-fits-all approach to solve this, so I'm going to show 3 strategies, and you would mix and match and choose which one suits you best. So the first one is fetchable processing. This strategy says that the webhook event is a notification. Ignore the data payload, and then what you do is you fetch the fresh data from the API, so Stripe's API, for example. So this example here, you can see this is actually a Stripe thin event. They're not sending the payload, the actual data, and then you'll use the related object ID to fetch the freshest state of that resource, and you'll use that as the source of truth. So you no longer need to worry about order because you're already getting the freshest data. But at scale, every event that you receive results in an API request. Now with Stripe, that's not too bad because you've got 100 requests a second, the API rate on most resources. But again, those other providers, they're probably not going to let you do 100 requests a second. And at any scale, right, if like there's a subscription renewal, a batch import triggers thousands and thousands of requests, you can't make API requests, even to Stripe, at that kind of rate. This is also only useful if you care about that current state because you're not persisting it. I wrote on stripe.dev about this approach or how you can use Hookdeck to solve it. But if that's of interest, there's a resource on stripe.dev. The second one is upsert by date. And this is where you have a transactional ACID compliant upsert upsert, so to insert or update the record if the incoming event is newer. So this is a Postgres example. And you've got an insert, and when there's a conflict, instead of doing the insert, you do an update based on a unique identifier, the subscription ID in this case, but only if the timestamp is newer. So you're ensuring that you're only updating the data if it's the newest piece of data available. This is really good for high throughput systems because then you're not making those API requests to fetch the data. You're obviously ensuring you've only got the latest version as well. You're going to avoid those API rate limits. But it only works if you're obviously storing the current state with the timestamps. It's got to be transactional, otherwise you're going to have clashes. The third one, the final one of these, is if you're not storing the full records, you can't compare those timestamps. Instead, use an ACID compliant store to track the processing status of that event. So when it comes in, if you've not seen that event ID before, then you go, okay, right, I've never seen this, I'm going to process it. If you come in, look at that ID, like we're processing it. What you need to do in this situation is reject that so that we don't know what's going to happen with that ongoing process. Is it going to succeed or fail? So that goes away. You can complete that process. When it comes back or when a new one comes in, you go, what's the status of this? If it's processed, you've already dealt with that. You can just ignore it. So enough about idempotency, and I won't have to say that again, which is good. So let's talk a little bit about architecture. So webhooks often arrive in bursts, as I've mentioned, those kind of subscription renewals, or just things that are going well on Black Friday, Cyber Monday. And during those operations, you'll see these kind of bursts in traffic. And capacity and timeouts aren't linear. So once you cross the threshold somewhere, so a CPU maxes out, threads are blocked, database connections are saturated, you're going to see this kind of exponential rise in problems and failure. So a small amount more of these events result in disproportionately worse performance. And then these systems will thankfully retry them to add to the problem. So you're dealing with the ongoing issue plus more events coming in as retries. So the solution to this is relatively simple, is your ingestion layer has to be completely decoupled from the processing layer. So put it very simply, ingest it, verify it, queue it, and process it asynchronously. So this is a diagram of components you can utilize in that sort of architecture. So API gateways, ingestion, serverless services, Lambda, Cloud Run. Then the storage layer where you've got queues and persisting data, logging, and then finally consumers that are reading off that queue and performing the logic. So the obvious takeaway there is decouple your ingestion from your processing, and if possible, nothing should ever fail in that ingestion layer. So you've queued those events. So how do you quickly process them? If you queue more than you can handle, you're going to get something called back pressure. So those delays can also increase over time. To handle that, you've got to understand a couple of things. You've got to understand how many events each of your processors, your processing instances, those workers can handle, and how many of those you can run safely. And from that, you can calculate your baseline, your maximum capacity. We look at queue depth, so how many events are on that queue, and then what's the oldest event on the queue, the maximum age. And from that, we kind of have this idea of time to clear, and I'll demo that in a little while. And then it tells you how long it'll take to clear that queue, and it gives us a real-time understanding of the health of the Hookdeck system. Back pressure is inevitable. The thing is, you've got to detect it before it's going to cause any problems and have a plan to deal with it. So eventually something will fail. You'll get a bad deploy, you'll get a server crash, you'll have some sort of broken worker. And if data integrity is important, you've got two options. The first one is I'll put this in simple terms. So it's to process or persist events. So you either know it's been successfully processed or you know it has been stored. You've got audit logs for that. You've got a dead letter queue for failed events. And if all those are fine, you know everything's working as it should be. The second option is to ignore all of that. And on any failure, refetch all the events and resynchronize the system and things downstream. So Stripe makes this easy because they've got Events API. Other platforms might require more tooling, more work. And depending on the volume of events, if you're processing thousands and thousands or millions of events, that's going to take time. As with anything, plan ahead for this. Don't wait until you've got a problem and then try and deal with it. Make sure you've got the tooling in place beforehand. So you've got these acts and knacks in place. You're making sure that you're auditing your system, everything's being successfully processed, but you might still lack visibility of where events are coming from, how they're being processing, how they're getting traced through the system. So you need to make sure you've got that traceability pushed through to a service such as Elasticsearch, Datadog. You can search historical events, debug issues, find specific things for customers if you're managing these webhooks, these events for your customers. And again, you need tooling to say, we didn't get that event, or we're not seeing this transaction reflected. You need the ability to rerun these events and push them through the system again. So ensure that you're building the tooling to support that functionality. Again, do it before there's any outage. So we've talked a lot about webhooks. Do you know that webhooks have been around since at least 2007? So someone called Jeff Lindsay eventually worked at Twilio, introduced webhooks didn't like polling, talked about it being a real-time system, maybe not real time, but so we've come a long way without a lot of change, but there's three things that I'm going to highlight I think are changing. Firstly, which is great to see, companies like Stripe and like Shopify are investing in this evented ecosystem. So, Stripe have got this thin events to allow that kind of fetch before process mechanism, because they're seeing that that's the way the developers are using webhooks. Shopify have introduced this idea to when you subscribe, filter on body content, not just on the event type. And also Stripe and Shopify and others are doing something called event destinations, which I'll talk about briefly next as well. And then I'll talk about event gateways with a demo, and then we'll finish. So event destinations, we feel this is quite a big shift. This is, you've probably seen it on the Stripe platform, right? Instead of subscribing to a webhook, you create an event destination of type. That type can be webhook, or that type can be AWS Event Bridge, and your events will be directly sent to a AWS Event Bridge. Shopify are doing the same. In fact, they're very much pushing for you to choose the option to send data directly to GCP PubSub or AWS Event Bridge. They do still offer webhooks. So whether you support Kinesis or webhooks. So webhooks are limited, right? I've waffled on for 10 minutes about some of the problems with webhooks. It won't take all the problems away from building event-driven architectures, but it will take some. There's not that standardization around webhooks, although there are attempts to do that. Security is opt-in. You can choose to whether you're going to validate a webhook or not, but many don't. And I know of large companies that have completely broken their webhook signing process, and very few customers have known about it or complained about it. Reliable ingestion infrastructure for HTTP does need to be built and managed and scaled. So directly integrating with message buses or event gateways can take a lot of these problems away. So Hookdeck is the main sponsor of eventdestinations.org. It's definitely inspired by Stripe. Stripe were the first company that we saw say event destinations. But we're trying to get contributions and feedback on the best guidelines for offering event destinations as part of products. We've also got an open source implementation of this written in Go that supports a number of different event destination types. It's also got a built-in portal and things. So if you're building an API, by all means look at Outpost and see if it might suit your needs if you want to offer event delivery within your product. I haven't checked my time, and no one's telling me off yet. So event gateways, demos, and then I will finish up. So event gateways, has anyone heard of Event Gateway before? No, okay. So it's a new thing. It is a new thing. We're trying to push for it being kind of a category. And the simple way of thinking about it is it's this asynchronous equivalent of an API gateway. It provides cloud structuring primitives for event-driven applications. And we compare ourselves to things like, and we see these other platforms as event gateways. So AWS Event Bridge, Google Event Arc, which probably no one's heard of either, and Azure Event Grid. But there are more competitors moving into this space because there are problems there. It's not massive yet, but there's definitely a movement. And it matters for all the reasons I've talked about, reliable ingestion of events, managing back pressure, filtering data, transforming data, routing it, I'm in the UK, routing it, retry handling, and observability. So I'll walk through some demos of how we've implemented this in Hookdeck, and then happy for some questions if we've got time. So I can't really see my screen here, so I'll have to turn here. So this is how you can use APIs or you can use the UI, but here I'm using Terraform to define resources. So we've got Stripe source, data's coming from Stripe. We're registering a webhook with Stripe. We've got a URL from Hookdeck, and we're saying, hey, this is a webhook endpoint. We're getting the webhook secret from Stripe. And then we're registering that in Hookdeck so that it can verify events are coming from Stripe. We're then creating an invoice endpoint, which can take 10 concurrent events at a time. So we will deliver them at that rate. There's another one with 10 events, but maximum of 10 events per minute. That's going to cause back pressure. We've got a connection, which is mapping the Stripe source to a destination. And we're saying we only want types of invoice dot that go to that endpoint. So only invoice events. And we're also doing kind of a sub-filter on subtotal value. So greater than 0. We're setting a retry rule as well there. Next, we've got a connection from the Stripe source through the subscription endpoint, making sure it only begins with customer.subscription. This is like our UI representation of sources, destinations, and the line makes it a connection. We can see that's authenticated. We can see like a histogram. We've got some additional, you can see the filters we set up. So the customer subscription on the subscription one, the invoice one has the subtotal, but also has the invoice dot prefix on the type. And then the endpoints, you can see the endpoint that's being delivered to, and also the delivery rate that we're setting on that. So I'll move forward onto the next one. So now we've kind of defined those routes and the way we're ingesting events. when you think we need to treat those connections as queues. So we went, okay, what is the throughput control on there? So remember the subscriptions API was 10 per minute. So we've got back pressure. We can see this blue represents pending events. Got lots of events that are building up in the queue, represented by pending here, and all these blue events. So we can drill into that. Okay, we've got a problem with back pressure. Additionally, remember I mentioned alerting. We've got this idea of issues. Here we go, okay, it's on the subscription API. We can drill into that a little bit more. We can obviously see there's the problem there. We can see there's 23 minutes of back pressure and 225 events sat in the queue. That's just going to build up. It's going to cause more problems. We can see lots of events have been triggered. There's a lot that are pending, and it's above our threshold. So we need to resolve this. So what we can do is we can go down, okay, this graph allows us to look at the response time of that endpoint. It's around 100 milliseconds. So we can definitely process more events. So we can go up to this section here and change the throughput to push more events through. And what that will do is that will clear that problem, release that back pressure. So it shows this clears the back pressure. It's now down to 3 minutes. Eventually the issue will resolve. So this is the sort of functionality you're going to want if you're working with webhooks or events at scale. So the last one is, when there are problems, you need to dig into your data and identify problems. So we've got this idea of logging on the platform. We can see all the events that are coming in. Say customers got in touch and said, I'm not seeing updated information based on some of the transactions I've seen that happened. So we can look at the body of events, find the customer, maybe we got that from them in the first place. And then we can filter, find more events from that customer. Right, okay, we can see a bunch of 500 errors. So obviously something's gone wrong there. That maps to what the customer's reporting. We can drill into that. We can see the requests and responses. This is actually a mock endpoint, but say we can see something going on here. There's a 500 error. We go and resolve the issue, right? We deploy, is it fixed? We'll rerun the event, right? We've got 200, everything's gonna be 200 okay. And then because there's been a 500 error, we've got another issue, we can drill into that. We can find any of those matching events, and then we can bulk retry them. So clear all those issues that we've seen already in the log. So 52 events here, so we'll retry them. So I know that these are Hookdeck demos, but to manage webhooks at scale, at events at scale, you'll need tooling like this. That's the point. You've got to have that observability, that tools to replay, help you dig into errors that you're seeing. And obviously the architecture in place as well to let you scale and ingest those events reliably and manage through to processing. So I've covered a bunch of things here, and I'm happy to take questions if there's time.